Hey all, what we'd like to do today is go through the code for our Arduino Notes project. So we taught you last time how to build this project, and what we're going to do is teach you the code part of it. So how does this thing work and what are the brains? That's what we're going to go through today. And I've pulled up the code here. This code is going to be shared in the description on our GitHub repository, so please check that out. And I'll try to just walk through it here for you. So, the first thing we're going to do is use this DF Mini MP3 library. There's a bunch of different libraries that you can use. I don't have any preference towards one, but this is what we're using for this one. And then, since we're using a lot of different components in this project, we just have our initialization for a lot of the things. Starting with our LCD, it's just determining the pin numbers for the RS, EN, D, and how they map back to the Arduino. And then we initialize our LCD object with those pins. For the keypad, basically I'm starting the keypad at pin 40. I'm using only the even pins so that I can line it up in a row in the back of the Arduino. So I'm saying how many pins to go and the base pin. And I'll show you down below that I just kind of iterate in a for loop through that. And just a common button state, whether it's high or low. A couple more things, like is note playing. We need to know that because essentially our DF player library is using callbacks, and what callbacks are is it basically is running in the background while your Arduino keeps processing. So if you say play note A, it's going to play a note and then come right back, and you're not going to know when that note's done. So what we need to do is serialize that a little bit better. And so I have a flag here that just tells me is a note playing, and then I can wait for that note to stop playing before I move on. And then finally what we do is we initialize the DF player, the MP3 player, on serial 3 here. So I have a video that I have on DF player troubleshooting, and I actually showed where my serial 2 is, I've blown it up. I've destroyed the pin on it. So you can move the DF player if you're using the Arduino Mega to different serial ports. Here we'll use 3. And then I just have some couple of game modes. So you have practice mode and you have gameplay mode. So I'm going to denote those here with some constants. And then we have the Simon notes. So this is the pattern. And what I do for the pattern is I create a 100 note array, and I just generate that at the beginning of the game. So it's not saying like here's one note, now play 2 notes, now play 3 notes. It's not creating that over and over again and adding to it. It's basically just as you play the game, it already has all the notes up to 100. Hopefully nobody gets to 100 because then my game will break. Total num tries, it's a lot harder to do this by ear, so I give you a couple tries. In Simon, as soon as you push that button that's wrong, you're done. Here it kind of plays it back a couple more times for you. And we have some different sounds. So when you play the DF player, the way that this library works is you have 001.mp3, 002.mp3, and you have different sounds that you can put in and as different files. And so I'm giving it the number on there. So basically, if you look at the MP3 drive, sound 001 through 007 are the notes A, B, C, D, E, F, and G. And then after that are some sound effects. Okay. So the sound effect, if you're correct, is 8.mp3 008. Sound if you're wrong is 9. Game over. And if it's your turn, so it indicates, hey, it's your turn via a sound. Okay, so we'll go through a couple, actually let's just spin all the way back to the bottom here. So let's go to the main function and see what's up, how this works. So the main function is going to be the loop. And how does this play? It plays pretty simple. First of all, set game mode. And then if the game mode is Simon, or is play the game, then it plays the Simon part, and then it plays the user part. And those are two different functions. Otherwise, the game mode is practice, and it runs the play piano function. So that's pretty easy. So let's look at these various methods here. So set game mode. What is it doing? So if the game mode's undefined, so basically if I've just started this, it has no game mode at all, then I'm going to start my LCD up. This is where I have output. And I ask the user, do you want to hit button 1 for practice or button 2 for play? Now, after we display that, we wait for the input, right? Wait for the user input. And how you do that is, while the game mode's undefined, I loop through all the pins. Well, basically, I only have to loop through the first 2 pins, but if I find that the user pushed button 1, then it's practice mode. Otherwise, it's play mode. And I just have a little bit of a sleep in between that loop, so it doesn't go crazy. And then once we've set the play mode, it's time to play, right? So let's get into more of the actual logic of the game. Let's look at setup. So what does setup need to do here? It sets up the serial port speed for your output, and then it sets up the LCD as a 20x4 display, and it goes through all the pins, and these are the num pins. These are your keypad pins, and it's setting them as input on the Arduino. Now that they're inputs, it initializes, it starts up the MP3 player object, and it gets card stats. And if you look at the DF player debugging video that I created, get card stats is pretty important, because if it's not hooked up right, it'll just put zeros back to you, and it won't have the right information there. So that helps you tell that everything's working and everything gets initialized with the DF player. And here's get card stats. Really, it's just going to print out the software version, the volume. If you wanted to set the serial volume here, you can. The software volume. If you wanted to set the software volume here, you can. But with a potentiometer that we have on our audio board, it doesn't matter. You can just turn the knob, and it tells you how many files it finds on your card, your SD card. So let's get into the actual Simon, right? So that well, actually, okay. So there's 2 methods really that come into play here. 2 game modes, right? There's practice. Practice is basically a piano. It's a glorified piano. So here is play piano, and this is what happens when you click on practice mode. So it'll essentially just set the LCD and say play a note. And you pick a button on the keypad, it waits for input here, it reads what key you've pressed. Let's go through this logic in a little bit more detail. So basically, in electronics, when you push a button, it's instantaneous, and it could be just a half a millisecond, or it could be for 20 seconds, right? But I'm trying to register a key press, and like a normal user would just press a key. So I need to know somewhere in between that. So what I would need to know is basically if this is a new button press, if I'm starting a new press, or if I'm holding down the button from last time. So I take so I record when the last button was pressed, right? And I give it an index of I. So I is the pin number. So I have an array of when this pin was pressed last. And if it was pressed more than 3 seconds ago, then it's a new key press, right? And I set this key press start to milliseconds. And what I'm trying to say is that user has to hold that button down for more than 100 milliseconds for it to be a good key press. So it's not just like a quick boop. It actually has to be registered for quite some time here. So down in the second part of this else statement, I say if now minus when it was pressed last is greater than 1,000 and it was a new key press, then it registered the key press. And note, so I have to figure out what note that is. Is it a C, a D, an E, or an F? Well, that's basically just, the base pin was 40. And so I'm just saying, well, what index am I on right now? And I'm calculating essentially what number of the key that the user pressed and assigning it a note. After I get the note, then it will play, sound, and wait note. Okay, so what's play, sound, and wait? It just sets is note playing equal true, and it plays that sound, the MP3 play folder track, and it just sits here and waits for the note to stop playing, right? So I said with this DF player, it uses callbacks, and so it will immediately return from play MP3 folder track. But I want it to be more serial than that. I want to wait for that note to finish. And so I just sit here in a while loop until it registers that the note's not playing anymore. Okay, so let's go through play Simon, right? So there's two parts of the actual game. There's play Simon and there's play user. So what does Simon have to do? Play Simon will have to come up with some series of notes to play you, and then you have to play them back, right? But this part is just what notes will it play. So first of all, it increments the note's length. So every time it iterates through, every time you get it right, you have to play more notes the next time around. So it starts at 1, then you have to do 2 notes and 3 notes. So it says my turn, and it'll print the status. Now print status is pretty cool. This is your score essentially. So it says what level you're on and how many tries left you have. So you have 3 tries to start out with, and the level is just the count. So you can see as you're playing how well you're doing. Okay, so back to play Simon. Print status. So it printed your score out, and now it is going to iterate through, so the for loop, it's going to go to the length of Simon notes length. So that's basically how long of a string that you have right now, and it's just going to play from that array. So that array was initialized at the very beginning, and it's going to play the index out of that array up until the length, and it uses this play and wait to play that note. That's pretty simple, right? So let's go to play user. So that's the second half of this. So play user, what it does is it says your turn, right? So Simon's saying it's your turn. Like I said last time, we want to be able to wait for when the user actually holds down the key. So we initialize everything to 0, but we're going to wait to detect an actual longer key press here. It plays a little sound that indicates it's your turn, and then it goes through this loop here. So it says keep reading keys from the user. So there's a main while loop that says I'm waiting, I'm basically expecting, let's say you're at level 3, I'm expecting 3 notes. So it's going to iterate through all these notes, waiting each time for you to press a key. So it will iterate through each pin on the board, so that's kind of like all the different keys, and wait for you to press something. So if button state equals high, first it detects like, hey, this is a first press, and then it detects that I've held it down for 200 milliseconds. So that's a good press. If that happens, then I increment our num user keys. So this is how many keys I've actually pressed. It starts at 0 and goes up, and that's how I can tell when I'm done. But it basically just calculates the note based on what pin you hit, plays that note, and now it's kind of the important part here is we have to check to see if you're right. Okay, did you press the right note in the key sequence? So basically, if you're not right, we want to know immediately. So what happens is it says, if the Simon notes, if the array of the original does not equal the note that I just pressed, then I'm going to go to the wrong answer function, right? And is correct is false. So it's going to kind of break out of this if I have the wrong. Well, it's not. It's going to print wrong answer if I have the wrong answer. So what is wrong answer? It says, "Oops, you are wrong," and then it plays the sound wrong, and it waits some time. Now it increments number of tries. Now if you are at your third time that you've gotten it wrong, then you actually lose the game. So here it will play the sound game over, say you lose, game over. If you didn't lose, then it will just play the sequence again, and you can play again. If you did lose, then it calls start over. Now start over is really kind of the function that initializes everything, and we haven't talked about this yet, but so this is what starts the notes game. It will, again, I mean, this is already in setup, but it will set the number of pins to input for the keypad. And then it'll say, welcome to notes. I'll play notes. You read them back. You play them back. It initializes a random seed because we're trying to create random notes, right? And this is where it generates the 100 value array of random values between 1 and 8. Those are the notes that Simon picked for this game. Also, I wait 7 seconds here because it's interesting. The DF player takes a couple of seconds to actually start up, and if you try and play notes before it's initialized itself, then it'll just explode. So I wait a little bit here, and we just set the variables again back to 0. So I have the notes length 0, number of tries 0. So let's go through some changes that I had to make to the actual code of this MP3 Notify. There's 2 changes that I had to make to get this to work. The first one is that if you look online in the forums, there's a thing called double invocation, and what happens is when it tries to play a note, it actually plays that note twice really quickly, and when it plays the note twice, it fails because the port's already in use, the device is already in use. So a quick fix for that is you just record the last time that you played a note, and if it's within a certain period of time, like really quick, you don't play it twice. So there's this little if statement that you can pop in here, and that'll help if it's playing it twice. It'll help to kind of stop that. So and the only other thing that I did is I have this note playing equals false. So when I start, it's a global variable. It's a little bit hacky, but when I start to play a note, I will set isNote playing to true, and then when this callback comes in and plays on play finished, then it will set isNote playing to false. And once that happens, I know that the play is finished and I can move on. Cool, so that pretty much concludes the code. So hope this helps you in your own projects, and have fun with your Arduinos.